So hello guys, welcome again to my channel GP Design, and in this video we are going to talk about the how to perform a CFD simulation on a Formula 1 front wing. As you can see, we have this front wing as well as the non-cone, which is performed in a CFD simulation, and you can interpret the result. So we will start from the basics. So let's get started. As you can see, I will delete my, let's say, I will delete my this study for now. Okay, yeah. So as you can see, we have our front wing model and with the nose cone. So we have assembled this part. In the assembly, we have two parts, which is the nose cone and the wing, as you can see. Now we want to perform a CFD simulation on it. So my flow is going in this direction. You have to measure the downforce, you have to measure the drag force as well as the coefficient of drag. So how to do that? What are the parameters we have to apply? What are the boundary conditions we have to apply? That we will discuss in this video. So for the turn on the CFD simulation in SolidWorks, what you have to do, if you have not available this flow simulation, so what you can do, you can just go to the add-ins and check your flow simulation, uh, this one, active add-ins. This is how you can active your any module, or else you can go to the SolidWorks add-ins as well and you can turn on your SolidWorks flow simulation, right? This one. I don't require SolidWorks simulation as of now. That's why I will keep it off. So it will take, yeah. Now I have enabled my flow simulation. Now I will start with first requirement is that you have to save your model in a particular directly to start the simulation. So I already saved this model already. Now what you can do, you can just go start with the wizard. See, this is your first step. So as you can see, we have this wizard, and we have to set up all types of boundary condition here. So I will rename my project. Let's say this is my front wing simulation, and I don't have any configuration for it. So I will keep it as it is, and my configuration name is default right now. If you want to add any comment, or if you want to add any description in it, so you can write down here, so that whenever you are generating report, it will come down there, right? So I don't have to change anything here. Yeah. So you have to select the unit system. What unit system you are going to use? Let's say I'm going to select the SI, and for pressure, Pascal, velocity for kilometer per hour, mass in a kg, length in a meter. Yeah. So according to your right, according to you, you can change your parameters over here. So you are done with the unit system for now. Now, what kind of analysis you are going to perform? Is it the external dynamics or internal simulation, right? So you have to choose between two. We don't have any internal type analysis. Internal type means whenever your flow is going through pipe, this can be counted as a internal simulation. And whenever you don't have any solid boundaries over your object, so it can be counted in the external simulation. So that's how you can differentiate between two. So you have to check the fluid flow. Yes, without fluid flow there is no simulation is there. So if you are going to perform a thermal simulation as well, or a heat transfer simulation, you can say, so you have to check the conduction as well. So you can define any material on it as well. I will click it off. And yeah, is it a time dependent or steady analysis? For now, I'm going to select the steady analysis because time dependent analysis will take a lot of time. So you can define your second, let's say 10 seconds you have to do, and what is the time step. So you can do 0.1. This is how you can perform the transient analysis. Is there a gravity include? Yes, gravity is include. That is downward direction. So I have to check whether it is a Z component. What I can do, I can just copy this and yeah, can put it here. What it tells, I will click it to 0. Okay, fine. So this is my Y direction right now. Rotation, I don't have any rotation region in this simulation. Rotation region will help you to perform a turbo machinery simulation, just like a turbocharger, supercharger, any type of blower, or wind in a wind tunnels. So that kind of rotary objects you can add in the rotation. But for now, I don't have any rotation and free surface. I don't have any free surface for now. Free surface only support the time dependent analysis. As you can see, free surface require enabling the time dependency. The time dependent analysis will be automatically enabled. So it will take a lot of time in a free surface, and I will discuss this topic later in a future video. Yeah. Now, what you have to select, which material you are going to apply to flow. Let's say I'm going to select the air only. So if you need any gases over here, or yeah, you can build your new material as well. And is it the flow is laminar or turbulent? So you can select over here laminar only, turbulent only. As your convenience, you can select this. Is there any humidity involved in the simulation? So for now, I will uncheck this and I will move ahead with this. So is there any thermal wall condition is there or not, right? So you can click it here. If any wall you have to apply differently, let's say you want to apply heat flux on the or a temperature you want to apply on the wall, so you can just go to the wall temperature, go to the this one, heat flux. But for now, my wall is adiabatic, no heat transfer is there. And also you can define your roughness value of your wall. Now in the final stage, you have to define a final parameters like at which velocity or at which speed the air is going to flow. So my air is going to flow in a z direction, which is this direction. So I will give it at 150. Okay, 150 is this direction. So what I can do, I can just click the minus value. So it's a negative 150 kilometer per hour is flowing. And what is the temperature of, as you can see, the ambient temperature, what it is. So you can define your ambient temperature as well. You can define your pressure, and also if you want to perform a simulation at particular amplitude, particular temperature or density, so you can click it here and select the altitude. According to the altitude, it will change the result in a pressure and temperature. So for now, I don't need this altitude, pressure and temperature. Okay, so it's enough, I think. Okay, so turbulence parameters. Okay, you keep it as it is, and if you have any dependency or time transient analysis if you are doing, then this will help you to do that, right? And in the parameter condition, okay, it is a user defined, not transfer. Also you can select the coordinate system as well. I don't think I have to change that. So I will click it to finish, and you will have a computational domain over here. As you can see, it is in a perspective mode. So I will click it off from the perspective mode. Now my computational domain is very large. For the large computational domain, I will have more computational time to compute the simulation. So what I will do, I will just click on it and I will change my You can also change the dimension from here, or else you can just go to the, just click the space and go to the side view and select the computational domain, and you reduce this. uh, yeah, this should be like this. From the front side, I will, yeah, great. Okay. Oh, yeah. So I'm done with my computational domain. So as you can see, my computational domain has been generated. Just to study the turbulence behind the front wing, I have keep my computational domain very long behind. Now, if you want to apply any boundary condition, extra boundary condition like a mass flow, volume flow, or the walls, real wall and ideal wall, or a environmental pressure, static pressure, whatever you want to apply, you can apply from here. I don't think it will help you in aerodynamics, but yes, if you are going to perform any close domain simulation, so it will help you a lot actually. In this simulation, you have to define some goals as well. So for the downforce, for the direct force, you have to apply some uh, this one goals. So in the global goals, you can apply, you can calculate the parameters for the whole geometry. Let's say I want to select the this one maximum velocity for a bulk average. I will select the maximum velocity in the z direction. So I will click it on. So it will count my whole geometry's maximum velocity, then the force value, normal force value, whatever. So in the z direction, you will have a drag force, and y direction, you have a lift force or a down force, right? Also, you can select the frictional force as well. You can calculate, and you can just click it on. Then you will have the frictional force and the shear stress, as well as you can count. These are the parameters you can count or calculate through the simulation, right? So you can select accordingly. If you want your goals at particular surface, so what you can do, as you can see, I want force on this surface. So what you can do, I will just click the appearance of, because it is very disturbing right now. This is, yeah, just I will remove the appearance. Yeah, and shadow is off. Yeah, great. Now it's looking good. If you want to calculate at this portion what are the forces, so you can just select the surface and select the parameter which you want to calculate. Not just the surface, even you can count the or calculate the point. Let's say at this point I want to calculate the force, the velocity, anything you want to calculate, you can do by the surface goals. Also, you have one equation goal which we will talk about in a future videos. You can also input your expression to find the CD, like a drag force you can calculate, area you can calculate, and automatically it will take you to the CD, your coefficient of drag value. So we will discuss this later because it will take a lot of time to generate the equation. So yeah, next part is your mesh. So if you want to create a local mesh, then you can select the refined cells higher, the level of refining cells, your channels, everything you can set accordingly, right? So you have to select road faces on which you have to apply the mesh controls. But for now, I will select the auto mesh for now, global mesh, which is having setting automatic. Okay, level of initial mesh, I will do around 5. So basic mesh, okay, this is fine actually. Uniform mesh, no for now. It was 75 mesh, no. I will click it, okay. Yeah, my mesh has been done right now. Now what I will do, I have to calculate this result what I'm getting, right? So what you can do, you can just go to the solve and calculate a control option. Whatever iteration, whatever parameters you have to set up, you can change from here. Also, you can define the refinement level. You can do the scale factor, if this is average or not, calculate the local mean average. Everything you can change from here as a solver control. After you are done with the solver control, what you can do, you can just go to the run and it will run your this. So you have codes, how many codes you have, you can just find out in your task manager and you can select from here. I will say use all, right? And yeah, batch result. So if you want to generate one report, you can just directly import your result into the report. Right? I will click it and run. So whenever you run the project, so it will get you to the one window where you will see your results are actually running, right? So yeah, this is preparing model right now, and this window is your log window, and this is your simulation info where the total cells, fluid cells, your CPU time, and what time the calculation will take. That will be in this one. Yeah. So as you can see, my pressure plot has been generated over here. I cannot see right now because it is still calculating. So what you can do, you can just go to the, I will go to model, which is my, wait, top notch. So it might, right, okay. In a right plane as a reference, I want to calculate the velocity live. I want to see the velocity live. So what you can do, you can just go to the image attributes. You can 1000 by 1000 image size, the HD image I want to see. You can also save the video, save the images, display mesh, okay. Region, okay. Isolines, I don't want. Yeah. As you can see, my airfoil has been calculated. For now, I will select the image size a bit higher so you can see what is happening, right? You can save this file into image. Right. I will insert it 1000 and yeah, 4000. Okay. Yeah, as you can see, it is calculating the iterations. I will also go to the info file where is calculation time left. Okay, 17, okay, 18. Iteration per travel is a 104, and my fluid cells are very higher actually. The number of cores is 20. It will take a few minutes to calculate. Till then, we will see. As you can see, my effect is going at this far. So that's why I took the computational domain very large from the behind. That's why. Right? So these are the windows you have opened. You can select or control from here. Also, you can insert the goal table as well. If your goals are converging or not, you can see from here your criteria is there, your average value is there, and what is the current value of airflow. That you can calculate. And also, you can just layout, organize. So if you have many simulation running on, so you can just manage them by this one. And also, if you want to suspend your analysis, go to suspend, and also the calculation control options is still available for you to change. Right? So these are some basic options you can just play with that. I will select more parameters like if you want to go to the ISO lines, it will, yeah, as you can see, my effect is this much higher. So we will wait till the my iteration has been calculated. 88, 89, and list of goals. It will take some time to convert the value. Right, this is my log file where the mesh generation started, calculation started. Okay, I will select this graph and go to the maximum velocity. So as you can see, these are my iteration is counting, and this is my velocity plot value. So as you can see from the 0 to this level, 74 is their value at a 10 iteration. My 64 is value is there, and maximum velocity is here, right? So this is how you can see your averaging. So my progress is around 30%. It will take some few minutes to get calculated. Also, you can go to the minimum maximum where your minimum is 0 for now, maximum is 187.615. Oh, wow. That's quite high. Also, till the time it has been calculated, so we can go to the this one help, or you can say the basics of CFD analysis, or which command is useful for what. So you can just go to the goal table, minimum maximum table, refinement table. It will tell you some basics of it, so you can start from that. Okay, how much is 7 minutes are remaining for now? Even I have the 20 codes, it will take a lot of time. So please give matching accordingly, or you can define your own iterations to get calculated, right? So that's depends on you. Okay, 2 minutes remaining. My goal is finally going to be converged in 2 minutes. Let's see what is happening right here. Okay, 3 minutes still going on. Also, you can stop your calculation from here. Let's say I will suspend the analysis for now. Okay, it is going to be completed, so I will not touch for, okay, 210, and yeah. Okay, this has been completed. What you can do, you can just go to the results. How you can load the result? You can just click it on, and if your results are not there, then you can just click on load, right? So how you interpret your result? This is the post-processing area where you can see the cut plots, where you can see the surface plot, the meshings, and your flow trajectories. I love flow trajectories in the SolidWorks the way it is showing, actually you have to be smart to showcase the base trajectories, flow trajectories. So what you can do, what normal guys will do is they will just select the plane and drag it here and apply the 500 flow trajectories, right? So what it does this kind of flow trajectories, which is not actually great way to represent your post-process region. So what you can do, you can just delete it, and what smart guys doing, they will just select whatever surface, on whatever surface they want the flow, they will select the surface like this, right? Let's say I am selecting these surfaces for now, yeah, and I will select, let's say, 500, and I want to select the line with the arrows, one, and then yeah. So as you can see, this is the pressure I want to select as a velocity. Okay, the arrows are much bigger. So what you can do, you can just go to the array and go to the flat arrows. Now it looks so much so good. Yeah. So as you can see, we have the turbulence over here. It is clearly showing your flow direction. How is your flow going, right? So this is how you can interpret your result. Also, you can just go to the surface plot and see what is happening on your surfaces. So you can just click on it, and velocity will be 0, obviously. What you can select the pressure value. So yeah, pressure difference is there on the surfaces. So this is the one legend where you can see what is the values coming. Now we have the cut plots over here. You can select the cut plots and select the plane accordingly. I drag it here and select the ISO lines, and yeah, select the contours, ISO lines. Yes. Now I will select the velocity. Okay. Now it's better to interpret your result, and now we will see how your goals are visible to you. What is the maximum velocity is taking the place. So you can just go to the goal plot, and you can just go to show. So it will tell you the value, the average value, minimum value, and maximum value it is coming. And what is the progress? Is it converged or not? And what is the delta? And what is the criteria? It will show you. If you want the graph of it, you can just go to the history, and it will show you the graph how it is going actually. Right. Also, you can export this data to your Excel file, so you can show it to your mentor or whoever you want to uh, show, right? So this is how you can perform a basic simulation of Formula One front wing. This is the basic boundary condition I have explained, and some of post processing I have explained. In future video, we will do a particle study. We will perform the custom mesh size and compare it with the ANSYS fluent. What is the difference and what are the values are coming, right? Is the fluent is better than SolidWorks flow simulation or not? And what kind of advantage it will give? So that we will discuss in the future video. Till then, keep sharing, keep loving, and keep learning. Thank you so much.